When a researcher sets out to do a project, to do a scientific study, they often have to identify what are the variables that they want to measure so that their study is successful. And so a lot of times they have to figure out if they want to count how many fish are in a stream, or if they want to look at how many different types of plants or insects are in the stream. They have to choose which one so that they can have the most effective experimental design. And one of the benefits of working in Hawaii is that we really don't know a lot about the streams in Hawaii or across the Pacific for that matter. And so when I set out to design an experiment, so for example, if I wanted to look at how mosquito fish are affecting our native gobies, I'm in sort of a better situation because no matter what variable I pick, even if I don't see a difference between a mosquito fish invaded stream and a native stream, I'm still increasing our understanding of how streams in Hawaii and in the Pacific function. And so it makes it a little easier from my standpoint when I'm setting out to set up or design an experiment to ask or test a hypothesis. A few years ago, we were curious to see how mosquito fish and swordtails, again, these are the pisciliids, exotic fish, we were curious how they were impacting our native gobies in the Hawaiian streams on Hawaii Island. And so we set out in the first to essentially identify where our study sites would be. And this is probably the most critical part of the experimental design, because if you wanted to identify or examine how an invasive species is impacting a stream, you need to pick streams that are similar. And so we set out and we hiked and we hiked and we hiked, and we must have gone through at least 100 different streams. And we looked at what was the stream bottom like? Was it sandy? Was it muddy? Was it rocky? What were the trees around the stream? Were they native species? Were they non-native species? Was it an open stream? Was there a lot of sunlight that was hitting the stream bottom? Or was it a closed canopy? So was there a lot of shade? And so we set out, we identified several streams, and then we came back and we set them on the table and went through them and said, okay, these streams are all similar in that they have high canopy cover, so there's a lot of leaves shading the streams. There's large boulders in all of these streams. They're small. They're all approximately 10 feet wide. And then from those, so we went from about 100 streams to about 25 streams. We selected 4 streams that had only native gobies in them, and 4 streams that had native gobies and exotic mosquito fish and swordtail. That allows us to document differences in an invaded versus a native stream. And so again, it's important when you're setting up an experiment or designing an experiment that you collect some of this background information, because you want to be able to at the end of the day walk away and say, okay, we saw this difference, and we are pretty confident that it's due to the fact that there are non-native invasive fish in these streams. It's really important when you start to do an experimental design that you use methods that are accepted by other scientists, because when you go to report your results either in a talk or in a paper, you want to make sure that the method you're using is a valid one. And so there are 2 ways you can do that. One is you can go into the literature and you can read papers and you can identify methods that are accepted, that have been accepted by other scientists, and then you can use those in your experimental design, and then that essentially validates or supports that method. The second is you can prove that it's an effective method. So for example, we do visual surveys, which involves, again, putting a mask, a snorkel on, and getting into the water and counting how many fish or how many shrimp there are in a certain area. And while that has been shown to be an effective method, and there are papers that say this is a valid method, we were kind of just curious. We wanted to validate it ourselves. And so we did visual surveys and then followed that up by going back into the same streams and using nets and capturing the animals in the nets. And then we compared the numbers we got in the nets and the numbers we were seeing with the visual surveys. And we found that there was a very strong correlation. That is, the numbers agreed. And so we were very confident that the numbers we were seeing in the visual surveys represented the actual numbers of shrimp or fish that were living in the stream reach.
Visit the Natural Enquirer website for more information. There you'll find more about how to plan and test your question.